Okay, we're going to do a couple of more examples of this, you guys, and then I will give you the assignment that we'll work on that. You should be able to get it done in class, and I got a little activity at the end of class that we're going to do. Yes? Oh, yeah. First of all, everybody, take your bell work. Make sure your name is on it right now. If it's an excused absence, you still get your points. Just write excused absence. Make sure your score is on it and your name. Put it on the flapper board. For those who missed class, this was our bell work problem. We just added f plus g, then we subtracted f minus, and we went f minus g, and then we multiplied f times g. All right. You guys, if you'll look right up here at our objective, the other day when we had class, we did the first part of this objective. Okay, we learned how to write functions that describe a relationship between two quantities. That's with the cubes. Remember with cubes, and you had to write it as a table, a graph, and write an equation for it, right? Okay, today we're going to do the second part of this. We will also learn how to combine functions using arithmetic operations. That's what we just did on this bell work problem. And then we're going to learn how to do compositions of functions. Okay? So write that down. That is what's coming up next. Okay, I've broken this down into addition on this slide, subtraction on the next slide, and multiplication on the third slide. So if you look at this right here, we have three functions. We have f of x equals 3x, right up here. And we have g of x equals x minus 5, and we're asked to find f of x plus g of x. Okay, so f of x is which function right there? 3x. I'm going to use, does that not show up very well? I'll use blue. Does blue show up very well on that? 3x plus function g is x minus 5. We usually when we substitute values in like that, we usually put them in parentheses. However, with addition, do you really need parentheses? No, because it's not going to change any signs. All we have to do is combine like terms. If we combine like terms right there, what do we get? Yeah, 3x plus x makes 4x, and we have the minus 5, and there's our expression. And we've created this function 4x minus 5, okay? By the way, what's the domain of this function?
It's all real numbers.
Why is it all real numbers?
So it's a linear function.
Yeah, okay. And that's what I want you guys to look on each one of these when we get done with them. Is it linear, quadratic, or exponential? Well, this one is linear. How can you tell?
Because it's the constant because there's no square.
Yeah, it's x to the first power, isn't it? It's not squared, it's not cubed. Okay. All right, and it's a line, and whenever you have a line, how far does the line extend to the right? Forever. How far to the left? Forever. And is it continuous in between? Okay, and so it's all real numbers. I'll just put all reals. Okay, that is the domain. Remember, the domain is defined to be the x numbers that the function takes on, and this one will take on any real number in the real number system. Okay. All right, next one. Right here, we are given f of x minus g of x, and f of x and g of x are the same two functions as last one. And so we have 3x, and then here's a subtract sign, minus x minus 5. Now, this one, do we need parentheses with? Why? Why, Stephanie? Okay, because, yeah, we want to we want to subtract both terms. You guys get that? And so if I didn't put parentheses, look how this problem changes. If I did not put parentheses, what should change that didn't change? The 5 should be positive, right? So that one's incorrect right there. So right here, you can think of this as like a -1 and distributing. It's going to change the signs to that. It's going to be minus x and a plus 5. Okay, do we understand that? Okay, combine like terms. What do you get, Drake? 2x plus 5 is our answer, right? That's our answer. What's the first of all, is this linear, exponential, or quadratic? Linear. And what's the domain? All real numbers. Okay. Next one, we're going to do f times g. F times g. And, well, I would FOIL, except for we don't need to. Why?
F of x is only one number.
Yeah, it's one term. Monomial times a binomial, right? If I have a monomial times a binomial, I don't need to FOIL. Okay? But I do need to distribute. What is the answer going to be right here? Minus what? 15x. All I did is multiplied 3x times x and 3x times negative 5. Any questions there? It is quadratic. Okay, so if this is a quadratic function instead of linear, what's the domain? It's all reals? What do you think? Yeah, even though it's going up to the right and up to the left, it's going forever right and left, and it's continuous in between, so the domain is all reals. Okay, any questions there? All right, next one. Oh, let's do one like this. Okay, here we go. Given these two functions, f of x equals x squared plus 4, and g of x equals 5x minus 6, I want you guys to do the following. Find f plus g, f minus g, and f times g. Okay, I'm going to give you 1 minute to work on these. I want you to check with your shoulder partner, see if you get the same answers on each of them, and then we will go over them. Okay, let's go over this. You guys, number 1, f plus g. I have function f, which is x squared plus 4, plus function g, which is 5x minus 6. All right. Do we need parentheses here? Not with addition, right? All I have to do is combine like terms. Do I have any like terms?
4 and 6.
Which ones?
4 and 6.
4 and negative 6, right? This is x squared, and this is just x to the first power, so they're not like terms, are they? They have to have the same degree. So x squared plus 5x, 4 minus 6 is negative 2. Raise your hand if that's what you got for your answer. Everybody, they got it. Check it. I want to see how we did. Okay? All right, good. I think all of you raised your hand. Okay, next one. X squared plus 4, subtract, parentheses, 5x minus 6. Remember, I have to use parentheses when I subtract so that I subtract both terms, the 5x and the negative 6. Okay, now, think of that minus sign as distributing a negative 1 through there, so that's going to be minus 5x plus 6. It's going to change the signs of the 5x and the negative 6. So if I combine like terms, what am I going to get? X squared minus 5x plus 10. Raise your hand if that is what you got for that one. Okay. What's your question?
Okay, so couldn't you just, like, you didn't have to put the parentheses right?
And what are you saying? You're saying we can just go to this step?
It wouldn't be plus 10. It's 4 minus 6.
Well, remember, if we were combining right here, we'd go 4 minus a negative 6. What happens when you minus a negative number? You add. It would be 4 plus 6, which is 10.
So, yeah, that's what I did. I got it, but it's right. I'm putting the negative 1 instead. It'd be 4 minus 1.
Well, if I go negative 1 times 5x, I get negative 5x. And negative 1 times negative 6 is a positive 6. 4 plus 6 is 10. Well, we did. We subtracted the 5x and we strapped 5x, and then we subtracted a negative 6, which makes it a positive 6.
So can you do it without the parentheses too?
Well, if I would have written this, like maybe this is what we're talking about. If I would have written x squared plus 4x, huh? Oh, plus 4, I'm sorry. I'm trying to, my shadow's in the way. Plus 4, and then I would, minus 5x minus 6, I wouldn't have gotten the same answer, would have I? 4 minus 6? That minus is for that 5x right there. Because there's no parentheses there. Well, I am. That's why, if I'm going to subtract the quantity, that's why you have to have parentheses. You could, I guess, if it's in the back of your head, but it's still there. Well, just think of changing the signs, Drake. Yeah. We did subtract the whole quantity. But if you write it like this, it's not saying subtract the whole quantity. If you want to make up a notation and we call it the Drake notation, we can. Yeah. Yeah. Now I'm starting to get confused. No. Y- Right. All right. We're moving on. Okay, Drake, if you got it down your head that way, you do it that way, okay? All right. You don't have it down your head, or you do? Okay. All right. Now we're going to do f times g. What are the two functions again? X squared plus 4 times 5x minus 6, right? I'm going to cross that out. That's not right. Okay? Is that the two? Because I went down, you guys. Is that the right things? Okay. So if we're doing this, we have to distribute, right? X squared times 5x. What is that? 5x cubed. And x squared times negative 6 is negative 6x squared. And then we got to distribute the 4. 4 times 5x is plus 20x. And then 4 times negative 6 is negative 24. Do we have any like terms to combine? No like terms, so there's your answer. How many of you guys get that as your answer? Okay, it should be a cubic function. It should look something like either like this or like that. Which one does it look like, left or the right one? It's littler. A little curve. Oh, so it's more like this. Yeah. That's called this is a cubic function. Okay. All right. Hey, these guys told me, Scott, that they're asking me who you were, so I told them I'd introduce you when you got back. Guys, this is Mr. Scott Cooper. This is Mr. Scott Cooper. He's a student at SUU. He thinks he wants to be a math teacher someday. So he has a class right now that you have to come down here. Was it like 8 or 9 times? This is your last time, right? But it's the first time he's been to this class. Is that right? Yeah. All right. So he's been some of my other classes. So anyway, today when we're doing some of the stuff, he's going to come around and help you, so you can ask him questions too. Okay? All right. Next thing we're going to learn, you guys, this is called combining functions using arithmetic operations. Now we're going to do the compositions, okay? So I want you to look at this right here, okay? Drake, we got more parentheses for you. That's what you wanted, right? Okay. The composition, I want you guys to think about this first. The composition of the function f with the function g is given by, you're going to make a new function called h of x. And how you're going to get that is you're going to do f of g of x. Now, I want you guys to think of this. I'm going to go to a new slide for a second, and I'll come back to that one. I want you to think about this. Let's say you had a function called f of x equals 5x minus 6. And I told you to find f of 2. What does that mean?
X equals 2.
X equals 2. So what am I going to do with the 2?
You get 2.
I'm going to substitute it in for x, right? So I evaluate that, and I get 10 minus 6, which is 4, right? Okay? So when I did f of 2, you knew that meant to substitute 2 into this equation for x. How many of you knew that already? You should.
I knew it like once you wrote that up with X.
Okay. Yeah, I guess I should have made sure. How many of you guys, when did you learn this? Did you learn it last year? Is that when you learned it, or did you learn it in a previous class? What? Last year? Okay, last year. Okay, so that's called function notation you're substituting. Well, if we go back to this problem right here, our new function that we're going to get, h of x, is f composed of g of x. Think about this. Someone tell me what we're going to do right here to find our new function h of x. Okay, I'm going to give everybody a chance, Zach, and then I'll call on you. Raise your hand if you think you got it figured out. F of g of x. Think about what I just showed you. If I have f of 2, what does that mean? Okay, Zach, why don't you go ahead? And Eli, be ready to help out here.
So, put up X minus 3, is like 4 times X minus 3.
That's right.
Putting the g of X equation in for X.
Yep, exactly right. Okay? Did you guys hear that? This f of g of x, this means we're going to put g of x into function f. I'm going to take this x minus 3 right here, and we're going to put it into for that x right there. That's exactly what Zach just said. So our new function h of x is going to be, and I'm going to write it like this. I want you guys to put 4. We're going to write function g right now, function f. And in place of the x, we're going to put parentheses, and then we're going to do plus 2. Okay? So that's function f. But instead of putting x, we put the parentheses. And what are we going to put in for x? We're going to put function g, which is x minus 3, right? Now all we have to do is simplify that. What would that be? What would I have to do first? 4 times x minus 12 plus 2, which is going to be 4x minus 10. How many of you got that? Okay, good. 4x minus 10. What's the domain? All reals. What kind of function is it? Linear, because x is to the first power, right? Okay, good job. How many of you think you could do that again? Okay, I'm going to challenge you right here. Now find g of f of x. Now find g of f of x. When you think you have the answer, raise your hand. You can probably do it in your head real fast. Okay, you got 2 people to answer. 3, 4, 5, 6, 7, 8. Okay. I think the rest of you are probably stuck if you haven't got it right now. Okay? So let's look at this right here. What are we putting in for what, you guys? Yeah. We're putting function f into function g, right? So here's function f, we're going to put it, this time we're going to put this one in for that x right there. So g of x, we have x minus 3. But what goes in front for the x? Function f, which is 4x plus 2. And we just simplify that, which 2 minus 3 is negative 1. So 4x minus 1 is your answer. How many of you had that as your answer? Not that many of you raised your hand the first time. You guys got to be brave here when we do this, okay? All right, good job. All right, next one. Okay, here we have two functions. F of x equals 4x, g of x equals 2 minus x. Find f composed of g of x. I'm going to pause this for a second. By the way, we didn't say hi to those guys that are gone, so everybody say hi Stetson really loud. Hi Stetson. Hi Hunter. Hi JD. Say hi Hunter. Hi Hunter. Okay, say hi to JD and JD. Hi JD. Hi JD, I love you. Tell them to do their homework assignment. All right, okay. It shows that they're all four of them got medical excused absences, so we'll find out if they're really sick next time. Yeah.
JD's not sick. He just didn't want to go to school.
All right.
Yeah, Stetson was in driving this.
Stetson just knows I have these videos now. He helped me set them up, so Stetson's in trouble. All right. All right. Okay. We're going to do some stuff that they're not going to be able to do unless they were here. So, all right. Let's do this problem. Let's see. Who thinks they got the right answer for this one? Raise your hand. All right, here we go. We're going to find out. Okay. Our new function, h of x, is going to be by putting g into function f, right? So here's function f. It's 4 times x, which we're going to put parentheses. We're going to substitute g in for it, 2 minus x. We are going to distribute. We're going to get 8 minus 4x. And then probably the proper way to write this is negative 4x plus 8. How many of you got that as the answer? All right, what's the domain? No, 4x minus 8 is different. 8 minus 4x, you could leave it like 8 minus 4x, yes. But we usually write things in descending order of exponents, so we write the x first. Okay, the domain is what? All reals. Okay. All right, next slide. And then I'm going to give you guys a homework assignment. Actually, I'm going to do one more problem after this. Oh, wrong slide. Right here. Here we go. All right. That's the same problem, isn't it? All right. Guess it's time for this problem right here. Okay. I want to see if you guys can do this one. If f of x equals x squared minus 6, and g of x equals 4x minus 7, and I asked you to find f of g of 2, let's see who can figure this out. Raise your hand when you got the answer. Okay, you guys, the homework is just this stuff. Yeah, you'll get it done fast. We got a little activity at the end of class. You'll get this done in class. Okay, let me tell you which numbers we're doing. We're going to do 1 through 4. And then we are going to cross out 5, 6, 7, and 8. Not doing those.
Yeah, I didn't understand them.
And then I want you to do 9 through 23. Yeah. I only made the other class do half that many. Because they got mad at me for making you guys have got to do half as many as they did the other day, so I told them I'd make it up. Hey, don't tell them this, but this is a lot easier assignment than that other one, okay? So, you guys get the advantage right here. That's what I said. Huh? No, oh, don't worry about f divided by g on this, you guys. Cross out the f divided by g. We are not doing f divided by g. Okay, so, hey guys, I want you to go back. I'm going to do like number 18. What does number 18 say? Just while we're waiting right here. I'm going to x minus 15. So, what's f of x? Is it f of x? What is it? Someone tell me. Jacob.
Number 18.
Yeah, number 18. What does it say?
H, parentheses, F, parentheses, F.
Okay, so we're going to find h of 5. So I need to know what function h is. What is function h?
X2
X squared minus 1. And what's function f? 3x, that's it? Okay, you guys, number 18. This is all you have to do. First of all, I have to find f of 5, right? So, because that's the inside function. So I'm going to go down to f, and I'm going to put 5 in for x. What's 3 times 5? 15. So now I can replace, I can replace f of 5 with 15. Okay, so f of 5 was 15, so I replace it. And that means h of 15 means put 15 in for x, which is going to be 15 squared minus 1. Well, what's 15 squared? It's 225. Minus 1 is 224. Yes. Oh, yeah, there's plenty of room.
That's gonna be hard for me because I write it.
Okay. You can, if you want to get out a separate piece of paper and write it on it, I'm fine with that. Just staple it to it. Yeah, I want you to show your work. Okay. Hey, I did this more for the benefit those guys weren't here, but also so you guys could do it. I want you guys to look at 23. Very last problem. I'm just going to give you a hint. All you have to do, it's all three functions, right? Just work backwards. Work from the inside function, clear out to the outside function.
Wait, does that, the little dots, those are multiplication dots? Okay.
Where?
The ones
Oh,
like
I forgot to show you that notation. Let me show you this notation. You guys, if I have f of g of x, the other way of writing that is f composed like this of g of x. It means the same thing. They put this little circle. It's not a time sign. It means composed. It's composition. That's what all these are. They're compositions. So these two things mean the same thing. F of g of x means f composed of g of x. So that is the same notation. So you know. And you can do things backwards. You can do f composed of g, and then you can turn around and do g composed of f. You just need to know which function you're putting in which function. Tracy, do you have an answer? A question? Okay. So you guys have your homework. I want you to finish it, and then we're going to do the activity.